Deadly radiation, a chilling silence. There's only the low hum of a light wind. This is Mars. The dust beneath my feet rises with every step. Apart from the sound of my breath in my helmet, there's no sign of life. If I weren't wearing this suit, I wouldn't last even a few minutes. After that, absolute nothingness. Just as I'd lost all hope, something appears in that red storm. At first, I think it's an illusion, a mirage. But soon, the curtain of dust whipped by the wind parts. And suddenly, in the middle of this hell, a giant glass dome rises. In astonishment, I approach its door. I reach out to the panel. The door opens with a slight hissing sound. I step inside. The air is exactly 21 degrees. The humidity is 50%. It's lush and green inside. Pressure is ideal. Suddenly, everything changes. I take off my helmet and take a deep breath into my lungs. Everything looks far too perfect, as if it's been specially tuned for life. A closed ecosystem, working like clockwork. My eyes see it, but my mind objects. There is life right in the middle of Mars.
If you encountered such a thing, what would your first reaction be? Would you call it a coincidence? Or would you ask who set this up and how? I'm aware that this scene you've watched seems impossible. In fact, I made such an intro just to make you feel that. But now, let me remind you that we're in something far more incredible. When we scale it up, we're also inside a dome. Of course, it's not made of glass, but of physical constants. The universe. And our Earth is a tiny garden flourishing within it. Well, we live inside that garden. And the numbers at the heart of the universe, certain parameters, they sit right in that narrow range where this garden can sprout. It's a very delicate setting. The scientific world calls this fine-tuning. In this video, we'll open the door to our cosmic dome and look closely at the universe's control panel. Please don't fiddle with your device's sensitive settings. If you're ready, let's begin. What's the first thing that comes to mind when you hear fine-tuning of the universe? Like if the sun were 1 millimeter closer to Earth, we'd burn up. Or if it were a bit further away, we'd freeze. I'm sure you've heard this example very often from those around you. That in reality, that's not the case. We need to clarify this first, because this is a very misunderstood situation. The distance between the Earth and the Sun already changes constantly throughout the year. And it's not just a matter of millimeters, it varies by millions of kilometers. So let's put this cliche aside for now and look at the universe's true fine-tuning. What should we understand by fine-tuning? What kind of precision are we talking about? First, we need to set the scene, because the rest of this video will build upon this framework. If physical constants were dials, almost no setting could have produced a universe like this. I say almost because there's an unimaginably small chance. And we are here as a result of that chance coming to pass. So, does this situation require an explanation? Or do we just put it down to a lucky lottery win? I'll get into that shortly, but for now, stop and visualize this idea. Imagine a control panel behind the universe that no one can see. It has various adjustment knobs on it. Settings like gravity, the strong nuclear force, and the cosmological constant that determines expansion. These are set so precisely that if you moved them a fraction, never mind life, not even a universe where galaxies and stars could form would exist. In other words, the stage isn't even set. No galaxies, no stars, nothing at all. The universe would be like an infinite void without matter. It's not quite absolute nothingness, but it's close. I realise how difficult this is to imagine. You know the phrase, "my brain is fried"? That's exactly what happens when thinking about this. Speaking of nothingness, I'm reminded of this video I made months ago, which was also a real head-scratcher. In that video, we asked if there was nothingness before the universe. We asked, but sometimes you hit a brick wall when seeking answers to certain questions, and that was exactly one of those questions. But today, we're hitting a different kind of wall. Not the door to nothingness, but the universe's control panel. The universe doesn't just exist, it seems to be tuned specifically to allow for existence. There's a stage set here. Why are these values exactly in the range where stars can burn? Why are all these settings just right? I'm not just talking about Earth or life itself. There are certain thresholds that must be crossed before we even get to that. The first threshold is the stage. Can the universe set the stage? In other words, can matter come together to form galaxies? The second is continuity. Let's say stars did somehow form. Well, will they be able to last long enough? And the final threshold is diversity. Can the state become more complex? Elements like carbon and oxygen, chemistry. Everything's in a delicate balance. It's as if all thresholds were crossed simultaneously. Of course, first and foremost, the stage itself must be set, because nothing begins until the stage lights come on. Meaning, matter must first be able to congregate. For this, we need something specific. Gravity. I call it the cosmic glue. This force, like the universe's other settings, exists in a very delicate balance. According to physicist calculations, this ratio is 1 in 10 to the power of 40. So if gravity was stronger by even a tiny fraction, like adding 40 zeros after a 1, our universe would have turned into a massive black hole and collapsed in its very first seconds. If it were weak to the same degree, this time the curtains would close before the lights even came on. Those massive gas clouds spreading from the Big Bang would have remained as a pile of dust in the vast darkness of the universe without ever touching each other. Just like the atomic bonds holding the glass of this dome on Mars together. They were a bit weaker. That dome would fall apart in the first storm. This is why this fine-tuning in gravity is so important. Without that balance, there would be neither galaxies nor stars in the universe. Just a cosmic loneliness. Now, let me explain this delicate balance with an example like this. Imagine you've shot an arrow from one end of the universe to the other. That arrow hits a 1 centimeter target billions of light years away right in the center. It's thanks to that millimetric precision that we are here right now. We're talking about a probability so low it's beyond our comprehension. But the stage isn't just about the gathering of matter. Once gathered, it also mustn't disperse. While gravity pulls matter together, the expansion of the universe tries to pull everything away. That's why there's a second critical setting, the cosmological constant. This is the dial that adjusts the expansion rate of the universe. Rough calculations made with quantum field theory suggest that this value should be very large. But the value we observe is incredibly small. Theory and observation differ by a factor of exactly 10 to the power of 120, 10 to the power of 120 times. Even the number of atoms in the observable universe is around 10 to the power of 80. Can you imagine how large a number that is? Physicists liken this precision to this. Take a pencil and try to balance it on its sharp tip. Look, it falls in a second. Now imagine doing this for billions of years. This is the kind of precision we're talking about. So this dial needs to be set with a precision of 10 to the power of 120 decimal places, not just millimeters. If this number was slightly higher, matter would have dispersed before a star was even born. If it were a bit lower, the universe would have slowed down prematurely this time. The expansion could even have stopped and reversed. The curtain would have started to close while the stage was still being set. Now, let's say the stage is set. Will the lights be able to stay on for a long time on this stage? In other words, will the stars be able to live long enough? Because what we call a star is like the heart of the universe, innit? It doesn't just produce light, it also produces the raw materials that make the chemistry of the universe possible. Elements like carbon, oxygen and iron. What did Carl Sagan say? We are all made of star stuff. For example, it's difficult to produce carbon in the universe. In the heart of a star, 2 heliums must combine to form a momentary nucleus. But that nucleus is so unstable that it disperses in the blink of an eye. If a 3rd helium nucleus arrives in that tiny moment, carbon's born. And the critical detail that makes this process possible is this. Carbon-12 has a special energy level called the Hoyle state. And its name comes from Fred Hoyle. He's the astrophysicist who first calculated and pointed this out. You can think of this like a lock inside the star. When the right level is reached, the door opens and carbon is formed. By the way, make a note of the name Fred Hoyle, because this name sits right at the heart of the big question we're about to ask. Another critical setting is the strong nuclear force. This is what holds the atomic nucleus together. It's also a fine point here that determines the fate of stars. 0.007. This number represents how efficiently the stars burn. In the hearts of stars like the Sun, hydrogen fuses into helium. In this conversion, about 0.7% of the mass becomes energy. This is where the light and heat of the stars come from. Now brace yourselves. If this value was slightly lower, say 0.006, stars would ignite with much more difficulty and burn much more dimly and inefficiently. If it was 0.008, then stars would be much brighter but have much shorter lifespans. Just like the lights of this dome on Mars. If too much energy came in, it could blow a fuse. Or with too little energy, it might not light up at all. So what we call continuity is about how long the light of the universe can stay on. 13.8 billion years have passed, says the Big Bang, and that light is still burning. So how is chemistry possible in the universe? The answer to that lies in the electromagnetic force. Without this force, there would be no such thing as an atom. But it's not just about whether atoms exist or not. How do atoms form bonds? That's also important. If this force was slightly different, the size of atoms, the strength of bonds, and the rhythm of reactions would change. At certain values, chemistry would become impoverished. At others, critical molecules like water would behave quite differently. In other words, chemistry, the language of life, might not work as we know it. Everything seen inside this dome, the strength of the glass, the curves of the leaf, the chemistry of the air filling my lungs, depends on the same invisible rule. The rules of chemistry, written by the electromagnetic force. It's not over. There's one more fine-tuning here. Mass ratios. If the mass ratio of the electron to the proton changed, the balance of what we call a bond would also change. So it's not enough for the bond to just exist. It has to be just right. That's when carbon, oxygen, water, and finally that complex story we call life become possible. Now the stage is set. The lights are on. Chemistry has flourished. 3 thresholds were crossed simultaneously. Now we ask this question. Why? Why do these settings exist in such a delicate balance? There are 4 main answers to this question. Coincidence, selection, necessity, design. Let's start with the simplest explanation. Coincidence, the numbers just happen to align. Nature somehow took on these values. We don't know why. If you won the jackpot in a lottery, would you ask why it was you? Most of us would just put it down to luck, wouldn't we? According to this approach, what we call life is our cosmic lottery. But there's a difference at this point. In a lottery, the question is usually, who won it? The question here is different. How did this ticket turn out to be the winning one? Because it's not just about our existence. There's also a stage in the middle. Remember those 3 thresholds. Galaxies had to form, stars had to burn for a long time, and chemistry had to become enriched, right? The idea of chance doesn't reject this either. It says this could also have happened by coincidence. So all 3 thresholds could have been crossed by chance at the same time. Let's say they were crossed. There's still no answer to this question. Why did it happen like this? But what if this lottery isn't limited to a single draw? I mean, if there are many, even an infinite number of tickets, and if you enter the draw an infinite number of times, then the winning ticket will eventually be yours at some point. This explanation we call selection is built upon this very idea. This is known as the anthropic principle. According to this approach, these values might not have been selected just once. Perhaps there are infinite universes and the settings are different in each one. Now remember the Mars scene at the beginning of the video? Let's change that scenario just a little bit. Let's say there isn't just one dome on Mars, but countless domes. But only one of them contains life. And the one we encounter in our story is that very dome. The idea of selection says this about the universe. Maybe we're only asking this question because we're in the dome that permits life. Otherwise, we wouldn't even be alive. So according to this view, we aren't watching the universe from just anywhere. We're watching it from a room that specifically allows us to watch. The English author Douglas Adams has an analogy about this that I really like. A puddle wakes up one morning, looks around, and says to itself, "This hole I'm in fits me so perfectly. Every curve must have been made just for me." Yet the reality is quite the opposite. The hole wasn't made for the puddle. The puddle took that shape to adapt to the hole. This analogy answers the question, why are we here? Because we couldn't have been anywhere else. But the question, why does such a place exist, still remains unanswered. Now let's conduct a thought experiment. Suppose a prisoner is standing before a firing squad. It seems like a bit of a grim example, but don't worry. In this scenario, no one is going to get hurt. 20 sharpshooters. Let them all fire at once and let every single one miss. The prisoner might suppress his shot by saying, if I'd been shot, I couldn't question it. But the fact that he survived is still right there. So how on earth did they all manage to miss? Well, the anthropic principle says this. If we weren't here, we wouldn't be able to talk about it. So it explains the selection, but it can't explain on its own why the stage was set up this way. So yes, it sheds light on the questions. Why are we in this dome? But it can't explain why such a dome exists on Mars in the first place. And this is where we come to the third explanation. Necessity. Perhaps there's no lottery involved at all. I mean, what we call fine-tuning might be necessitated by a much deeper physics that we don't yet know. Maybe one day that physics will be discovered, and what we think are adjustment knobs will be a result of equations. Remember when we mentioned the control panel? It looks like there are knobs on the panel, but they might actually be locked. Maybe there's a circuit board behind it that only allows for one single setting. So the answer to the question, why 0.007? Could be because the equation makes it mandatory. So according to the equation, perhaps it was impossible for it to be any number other than 0.007. Now let's say that one day that profound physics is discovered. This time, other questions arise. Why did those equations take that exact form? Why did this inevitable physics produce a universe like this? This is where the fourth possibility comes to mind. Design. Outside this dome on Mars, there was nothing related to life, was there? Inside, all the ideal conditions for life were present. Remember at the start of the video, I asked what would first come to mind if you saw something like this? Most of us would probably ask, who designed this and put it here? Well, the design approach stems from a similar intuition. Having so many parameters in the same narrow range at once makes many of us think there's more to it than just chance. The idea of design is actually based on a very human reflex, the search for meaning. For instance, if you saw stones arranged meaningfully in a desert, like an arrow or coordinates, it would be hard to say the wind did it, wouldn't it? Yes, perhaps random processes can also produce certain shapes. But if those shapes are meaningful, one naturally asks the following question. Is there an intention behind this? You see, this question has even intrigued scientists who are skeptical of the idea of design. Take Fred Hoyle, whom we mentioned earlier, the man who calculated the critical energy level for carbon formation. He initially interpreted this as a coincidence. But as the years went by, he realized that these kinds of coincidences weren't limited to carbon. For instance, there's a delicate balance regarding oxygen as well. Under the same conditions, carbon mustn't immediately turn into oxygen and vanish. When Hoyle discovered this years later, he began to wonder if all these coincidences were truly accidental. He even made the following statement. A common sense interpretation of the facts suggests that a superintelligence has monkeyed with physics. Naturally, when a scientist like Hoyle says that, it makes you stop and think. Of course, the aim of this video isn't to convince anyone of an answer or to impose anything. That's why I've tried to remain impartial towards every approach. I wanted to broaden the questions in our minds. Thinking more, questioning more, these are good things. It reminds us of the sheer scale and grandeur of the universe. In any case, I think the answer to all these questions depends on where we look. We all look at the same view and see different things. Because within this view, there isn't just an answer, there's also a mirror. Some of us see chance, others see selection or necessity. While some see the design behind such fine-tuning, the possibility of intent. But whichever way we interpret it, one thing remains constant. We are inside this dome. Despite the eerie silence outside, there is life here. The fine-tuning argument doesn't give us a definitive answer, but it leaves us caught between these two questions. Was the cosmic stage set for us? Or are we here simply because the universe exists?